Hello, Mr. Burke.
Hello, Mr. Mazzolini.
So we've been studying gas laws,
We have.
and we've come up with some ideas, right?
Right.
And I think today is all about reviewing those concepts, right?
That sounds good to me.
Okay. So let's start off. You've written some things on the board,
Right.
and you have Boyle's law.
Right.
So why don't you tell us about Boyle's law?
Well, Boyle's law assumes that we have a constant temperature and a constant volume of gas, and it tells us when we multiply the pressure times the volume, we come up with a constant.
Okay. So what that means, if you increase pressure, what happens to the volume?
Volume's going to go
Line goes down. Okay, I see this plunger on your desk here.
Right.
So if we increase the pressure, you can sort of see that the volume definitely goes down, right?
Definitely.
Okay.
And if we think back to what we did in the lab a week or so ago, we did exactly that using the lab class.
Right, that's right. And we got a nice graph off of that.
We sure did.
You like green.
I do, for the Irish.
So you have pressure and volume.
Right.
If you graph that, I hope most of you got something that looked like this. Okay. And that is definitely, when you multiply those, you get a constant. When one goes up, one goes down. What is that called? What kind of relationship would that be?
They're moving in opposite directions, so they're inversely proportional.
Okay, so that's an inversely proportional relationship. I'm just going to put the word inverse there. Okay, so that's one of the laws.
Right.
How about the next one?
Second law looked at constant pressure, but we related temperature and volume to each other.
Okay.
Referred to as Charles's law, and it said that as temperature increased, the volume increased.
Temperature increases, the volume increases.
Right.
Okay, and that's
Difficult
yeah,
to show.
It is. But it does happen. Now, that equation is different. We're dividing these two
Right.
things. So if we were to graph this, we have volume and temperature now. We should do something like that.
Right. Because they are both moving in the same direction.
Correct.
So as we go up in temperature, our volume goes up as well.
And I think that's called directly proportional, right?
That would make sense.
Good. Okay, now I know my students really don't like knowing a lot of formulas. So we have what's called a combined gas law formula. So what is that about?
The combined gas law is just what it says. It combines Boyle's law and Charles's law to give us another constant. And the easy way to remember it is to think about our geography here in the valley, and we know that Paradise Valley is north of Tempe.
You need to know your geography.
You do have to know your geography.
So great. So that combines those two things.
Right.
Okay. But I know, we have pressure, volume, and temperature. But isn't there another way to change the pressure and volume of a gas?
Sure. What else are we talking about when we're looking at this? What are we measuring?
Well, we're measuring molecules of motion,
Mhm.
right? And molecules hitting things.
Right?
So I guess the more molecules you have hitting things, the higher the pressure,
Right.
or the higher the volume
Exactly. So how do we measure molecules?
in moles.
In moles. Exactly.
So back to moles. Don't forget moles.
No, can't forget moles.
Good
So
deal.
we combine our combined gas law with our concept of moles, and we represent moles by the letter N. And again, we found that pressure times volume divided by the number of moles times the temperature will give us a new constant, R,
And that is called the gas constant.
the gas constant. Exactly.
So just to put those things in perspective, maybe, we can do a couple more. We have pressure and moles.
Right.
Now, they look like the same thing that Charles' law was as far as division, right?
Right.
So they should produce the same graphs, right?
Right.
So they should be doing that.
Mhm.
And now we have the same situation with, it looks like, with volume and moles.
Mhm.
And so we should expect the same graph there.
Exactly.
Right. So we have 3 directly proportional graphs and 1 inversely proportional. Good. So really, they need to know how many formulas?
Well, technically, only one.
Just one. That's great. Good news for you guys. Thanks for watching.
Yep.